Hello, everyone. Thank you for coming to my presentation. My name is Jiang from the University of Melbourne. I'm going to present our work titled User Trust in Assisted Decision Making using Miniaturized Near-Infrared Spectroscopy. Here are the main takeaways for our study. One is to users trust and familiar technology in a real-life decision-making scenario. Why and how to improve the design for better trustfulness. Here is the context for our study. Imagine you want to buy gluten-free in the supermarket. Usually it's quite straightforward. By looking at the package, there's a big fronted gluten-free. However, there are cases that labels can be missing, such as homemade food, unreadable, such as in a foreign language, or even fake. In that case, you might need some assistance to help you to make decision on the gluten-free food. However, the challenge here is gluten-free food and gluten content food can be visually similar, which means it's hard for human eyes to identify which one is gluten-free. Here we use the technology called Near-Infrared Spectroscopy, or NIRS. It's an emerging technology, but unfamiliar for most of people like computer vision, but it's a very helpful tool to help you to identify the ingredients in food, such as the example we show here. So in this study, we're going to let participants use this technology by their own, which might be the first time for them. Here's the protocol for our study. 4 steps: inspection, scan, visualize, and choose trust. I'm going to give more details for each step now. The inspection is we will let participants to inspect the rocks by themselves and decide if it's gluten-free or not. We have 3 label conditions. The English label condition is the original commercial package. Then we made the Russian label conditions by translating the original English label conditions. As you can see, they look very similar, but in a foreign language. And then we made the no label condition, which is only the package without any information. Then we will let the participant use the scanner to scan the rocks by their own after a short training session. We customized a NIRS scanner look like this to improve the usability for the participants. We also customized a software with machine learning classifications. We also have an Android front end for the participant to control the scanner and also get results from the classifiers. Here's the results, the accuracy for these 2 steps. English label condition, no surprise, no one made a mistake on reading the labels. But the scanner here is not perfect because the technology is still ongoing development. However, for the Russian label condition and no label condition, the participants had much lower accuracy compared to the English label condition, which means it was a challenge for the participants to do so. However, for the scanners, the accuracy is much higher than the inspection accuracy, which means potentially can help participants to make a better decision if they trust them. Next, we'll visualize the results of the scanner by showing a confidence level of the scanner because it is not perfect. We have 3 visualization conditions with different dimensionalities. 0 dimension is the number, 1 dimension like a bar or a scale, 2 dimension like a grid or an icon array. All the 3 techniques are well known. Finally, we'll let participants choose if they trust the technology or not. As you can see, for all the 3 conditions, the trust ratio, even though it's not 100%, they are quite high, like more than 80%, which means the participant towards to trust the scanner, even though it's the first time they heard about that. Finally, based on all the 3 results, we calculate the final decision accuracy. And here is the performance. For the English label condition as a baseline, is 100%, is perfect for everyone. However, for the Russian label condition and no label condition, with the assistance of the NIRS scanner, the participant could make a much better decision accuracy compared to their own inspection performance. Which means with the help of NIRS, participants could make a better performance on such a task, and they do trust this scanner, even though it's the first time they use that. We have more findings in our paper. If you are interested in, please look at paper for more details. So finally, the main takeaways: do they trust? Yes. Why? Is because information availability and consensus, as we show more details in our paper. We also have the implementations for designs. Thank you for your attention.